Hello everyone, I'm Maddie, and today I'm doing a re-recording of a presentation I gave about a month ago for the UNSW Linux Society entitled You Might Not Need NixOS. NixOS is an extremely hyped distribution of Linux. It claims to offer many advantages over other systems, but I'm pretty sure that there are plenty of alternatives that can do everything that it does, but better. And as such, in this talk, I'm going to be trying to convince myself and all of you lovely viewers of this fact. So, in this talk, what I'll be discussing is, first of all, what do I care about as a computer user? What is Nix? What is NixOS? And then, what is it like to use it? And finally, are there any alternatives and are they better? So, first things first, what do I want from my system? It needs to be easy to configure. I don't want to be wasting my life bashing my head against a brick wall trying to get my computer to work. So I want to develop the software that I want to develop without needing tedious setup for all of my different projects. Notably, I have way too many side projects. So if I have to go and set all of those up in different ways over and over and over again, that's going to be incredibly annoying, and I want to avoid that. Next of all, it needs to be transparent. It should be very clear what is going on with my system. I don't want to have 5 different package managers if I'm able to avoid it. And then finally, it must be reliable. For me, breakages are a disaster. My system must always work when I need it to, and I should be able to decide when it is down for upgrades. So, previously, I used Fedora Linux, which is a pretty rock-solid distribution. Everything is installed with DNF, but then I installed some things with Flatpak if there wasn't an RPM available, and then if there wasn't a Flatpak or an RPM available, I would use the snap, which kind of sucks, but you take what you're given. Additionally, I used a tool called Mies for installing all of my developer tooling. We'll talk about that in a little bit. So, one notable thing is that it was configured entirely imperatively. So that means that in order to change something, I would need to go and run a command that would change the thing, or go and modify a settings dialog. So I found Fedora to be simple, fast, and reliable. Like, nothing important ever broke for me on Fedora. However, it would be very difficult to reproduce the system state. So let's say my laptop gets stolen or something, if I need to go and set up a new system, it's going to be real difficult to get the system back up and running with all of the features enabled straight away. I've just changed so many settings that it would take weeks to get everything up to the same standard. So, next question, what is Nix? So, Nix is a functional programming language and package manager, where the output of a Nix program determines packages and configurations usually used to build a software. So all the dependencies are built and stored in this thing called the Nix store, which is just like some massive database containing a buttload of files, and then they're linked together to be used in the currently running system. Notably though, every single package uses its own set of isolated dependencies, so it's impossible to end up in dependency hell. So as an example of this, one of the courses that I teach at UNSW requires us to use Java 17. I know, terrible, but we live with it. Anyway, there's one problem, which is that I really enjoy having proper editor support in terms of having a language server. But the language server for Java, JDTLS, it requires Java 21. That's a nightmare to configure on most systems, where you'll have JDK 17, and then you install JDTLS and it will refuse to run because it has an outdated version of Java. But it's not a problem on NixOS, because all I need to do is say I want JDK 17 and JDT language server, and JDT is going to go and get its very own copy of Java 21 in the Nix store without a single conflict. That's pretty cool. So now, what is NixOS? It's basically if we took that concept and turned it into an entire operating system. So every single package on the system and all the core system configurations like users, file system mounts, all that sort of thing are described in the Nix language. So there's no more learning random commands or editing random files. You basically set up everything in a single configuration. And additionally, that means you get atomic upgrades. So you get easy rollback if anything breaks, and if anything fails to install or something, then your entire system is just left at the previous state instead of having a half-changed system. So you can see in this configuration here, I'm able to do things like I can add additional file systems, I can rename the computer, I can set the time zone, I can create a user account, and many, many more things, all from one single computer program. And that's really powerful because as much as this sort of looks a little bit like a bit of a cooked version of JSON, it's actually a full-on functional programming language, as mentioned before, meaning that you could have if statements or case statements. I don't actually know if it's case statements or not, I haven't looked into that, but that sort of thing, you know? And it will be very, very powerful, especially if you need to maintain the same configuration across many, many different systems. So what is it up against? First of all, Mies, which is a development package and tool management system, and it's basically a single tool that installs and manages all of your development tools. So I use that to install the Java development kit, Python, NPM, Bun, Rust. Basically anything that I do software development with, I've installed it with Mies on my old system. Then I have Docker, which I use for consistent and easily deployable builds of software. So it gives you an isolated development environment if you want to develop stuff, and it gives you an isolated build or deployment of software. But there's only one way to find out how they actually compare. So I switched to NixOS. So basically, I set myself a self-imposed challenge where wherever possible, I tried to do things the NixOS way. So I intentionally avoided alternative tools when Nix claimed to be capable of solving one of those problems. I tried to use it for literally everything, but I kept Fedora installed just in case and avoided booting into it. In fact, I think I booted into it a total of once or twice. In particular, I used it for tutoring work, so running tutorials, giving presentations, marking students' work, as well as working on personal programming projects in Python and Node and Rust, and playing a couple of games. So what was it like? Imperfect. So first of all, rebuilding was really slow. So if I do a system update and it has to download all the new stuff, normally that's like a 5 minute sort of thing, 5 minutes to download and then a couple minutes to install. On NixOS, rebuilding would take well over 15 minutes if I was doing a system update, which really, really sucked. When I updated to NixOS 25.11 the other day, it took more than an hour and consumed more than 55 gigabytes of data for some reason. Even when you make 0 changes to your system, a rebuild will take a good 20 seconds. That's especially annoying because of the subpart editor support in Nix, meaning that most of the mistakes that I made were only detected at build time rather than as I type, which really slowed down the speed with which I could iterate. That's a real shame coming from excellent languages such as Rust and TypeScript. So yeah, I really wish that Nix was a statically typed language so that the editor support would be better. Like, obviously, the people who have made the language server and all that sort of thing, they've done incredibly hard work, and I don't mean to diss them, but it really felt worse compared to alternatives that I've used in other languages. The next thing is that I hope you like compiling. So while popular packages are cached, it is technically a source-based distribution, so if you try and build something that isn't in their cache, then it's going to compile it from source. Notably, I tried to install CUDA, big mistake. Big mistake. Don't try to install CUDA, never try to install CUDA. If you customize a package in any way, for example by telling it to add additional dependencies, sometimes it'll just compile the entire package from source, even if those dependencies can be dynamically linked. For example, I wanted to give VLC access to lib Blu-ray in Java so that I could play Blu-rays in it, and instead of downloading VLC then adding the dynamic library to its path, it decided to compile all of VLC and all of its dependencies from source. Lovely. And then, when I updated to NixOS 25.11, it decided that it would compile Chromium from source. For those unfamiliar, Chromium, the thing behind Google Chrome, takes about, on an extremely fast server, probably about an hour and a half to compile. On a reasonably old laptop such as mine, it would probably take upwards of 8 hours. I had to cancel it after waiting almost 3 hours with no sign of stopping, 100% CPU usage, system basically unusable for that whole time. It was not fun. So, like, as a side note, one of the other things that I found was that when it did decide to compile Chromium, it was really hard to figure out why it was doing so. Like, the actual reason ended up being a program, the Jellyfin media player, until, like, today, used a really ancient version of Chromium for its Electron base. And as such, that got removed from the cache because it was old and insecure, which is fair enough. But the thing is, I couldn't figure out why I was compiling Chromium because, like, I just saw, yeah, it's compiling Chromium. I didn't see any kind of indication of what thing had Chromium as a dependency. So eventually I found a tool called NH, or Nix Helper, and it had a really good terminal user interface for like troubleshooting those issues that I encountered. Like in particular, it told me what was taking so long to compile, which begs the question, why is that not the default? Like, seriously, the user experience of using Nix's default tools was awful, and it made so many troubleshooting steps needlessly difficult, especially as a new user. It was really, really frustrating. Also, documentation was not great. So there's no single source of truth for figuring out how NixOS works. There's 2 different wikis for some reason, and often you'll have to scour forum posts to find answers, and sometimes you'll literally be reading the source code of their Git repos to try and figure out what's going on. The moment you want to do anything non-trivial, you'll quickly run into issues, and you'll be sent off on a Google hunt, which was not fun. Like, trying to set up anything remotely complicated just left me in documentation hell, basically. Finally, there were quite a few bits of jank. So, for example, some of my apps, they didn't keep their icons while open, instead getting this generic executable icon, meaning that it was really hard to tell what was what, because you'd put your mouse over it and it would have a generic executable icon and then say unknown on the tooltip. Really, really annoying. Additionally, my laptop seems to be convinced that it's connected via Ethernet, even though it absolutely isn't. Like, it's connected over Wi-Fi, guys. Come on, get with the program. Occasionally, also, my apps would all disappear from the launcher after a rebuild, which was terrifying. I thought I'd accidentally deleted half the apps on my system. Awful stuff. Even still, when things did work, they worked very consistently. In fact, I found that some of the apps that I tried were even more stable than they were on Fedora. But let's get into a couple of more specific uses. So, what was it like for programming? The fact is that it's not possible to globally install multiple versions of a tool side by side, and that's pretty annoying, because sometimes I have some projects that require Node 20 and some that require Node 22, that sort of thing, and that's really frustrating. For interpreter language, everything except for binary dependencies worked fine, but otherwise I'd manually need to configure dev shells for some of my projects, where a dev shell is basically the system-wide equivalent of a Python virtual environment with its own isolated set of dependencies. That's cool that that exists, and they work well once you set them up, but the setup process is incredibly tedious. For example, check out this dev shell configuration I had to set up for the slideshow viewer that I'm using in this very presentation. Yeah. That isn't all either, because I need to create a wrapper package, because you can't wrap a package that hasn't been nixed unless you fork its source code. So I needed to go and create this empty Python package and say, and with a print statement saying, I need this to be here, otherwise it fails to build, because otherwise I literally couldn't build it, because I didn't want to add the Nix code into the original package, because I wasn't sure if I was going to be sticking with NixOS or not. So essentially, you need to add one of those sorts of configurations to many of the repositories you want to work with, even if it has any form of complex dependencies at all. That is a ton of work to do, especially if you have many side projects like me. Even then, I was still completely unable to get it to work for some software. For example, one of the tools that I use and develop depends on PyQt, which straight up refused to build entirely. I could spend another 3 hours debugging it and reading incomprehensible Nix build errors, but I just really didn't feel like it. So, next thing, gaming. What is it like for gaming? Yeah, those random splotches, they're brought to you by GNOME. However, what if I use a desktop that isn't awful? With literally just 2 lines of configuration, I was able to set up and configure GameScope, which is the session that's used by SteamOS, and it literally just worked. 2 lines in my configuration, and I just get an option to boot into GameScope from my login screen. That's awesome. For comparison, on most other distros, you would need to run a buttload of random scripts to get it to work, and even then, it'd probably break in the future. But yeah, I was able to boot into GameScope and play my games with GPU acceleration and everything, for the most part, and it was really, really good. I was super, super impressed by that. But yeah, that GPU support, yeah, the games were running a little bit badly, so I was about to enable all the features by hand, like enabling all of the, NVIDIA drives and that sort of thing, when I discovered that NixOS has a hardware configuration repository up on GitHub, which has complete configurations for my laptop and probably thousands of others, and literally all I needed to do was import it. And then add a couple lines to my configuration, and now I've got ready-made hardware configuration specifically for my system, which will automatically set up my GPU and a bunch of other things with a perfect configuration specifically for my laptop. That is awesome. I cannot stress enough how cool this felt when I discovered it. And now, whenever I want to run a game with a GPU, I just need to modify the launch options for the game in Steam to be like NVIDIA offload command. And why doesn't that work automatically? I don't know. And I couldn't figure out how to just make Steam run using my dedicated GPU entirely, for example, by making Steam actually run NVIDIA offload Steam. But also I couldn't get that working on Fedora, so I won't judge too hard for NVIDIA issues. So, next question. What on earth is a flake? So, you know how I complained about NixOS being a bit slow to rebuild? Kind of like a package lock JSON in Node, a flake stores the resolved dependencies so that they don't need to be recalculated every single time. That sounds great, right? Wrong. I managed to break my system entirely by trying and presumably failing to convert my configuration to a flake. I couldn't even run NixOS rebuild to try to rebuild an old working version. I got this crazy error in someone else's source code. Awful, awful stuff. It was a nightmare. Thankfully, one of the really good things about NixOS is that it has this thing called generations, where it stores a bunch of generations of previous states of your system. So all I needed to do to get back to a working system was reboot, and then instead of choosing the current generation, I chose one a couple of versions old, and then booted into that, and then I was able to rebuild to the fixed configuration. That was so helpful, and I imagine that if I run into any configuration issues when I'm on a short deadline in the future, I'm going to be able to take advantage of this feature to always have a working system. Incredibly helpful. So I tried Flakes again, and for my second attempt, I decided to keep my main configuration as a regular Nix configuration and just use Flakes for other parts. For example, in comp2511, I need Gradle 8.8, which is pretty old. Accessing that old version from NixOS's history is much easier when you just put in a flake so that you can have the separate inputs and outputs. So I say Gradle 8.8 inputs and set the Nix packages URL to be this crazy commit hash, and when you do that, now you have Gradle 8.8. And it's not great, I have to find a commit hash and stuff, but it's not horrible. So yeah, how else are flakes useful? Let's go and let's turn comp1511's DCC compiler into a flake. It's got some pretty tough requirements because it's a bit of a mess of code. So it has many build dependencies. It depends on Python, Clang, GNU Make, and more. Some of those are also compiler runtime dependencies. It depends on both Clang and GCC for some reason. And we don't want to needlessly pollute our runtime environment with those dependencies, especially since the user may desire different versions of them. However, there's still some kind of compiled app runtime dependencies, such as GDB and Valgrind, because if you compile something with DCC, then it's going to automatically call Valgrind on startup, and it's automatically going to call GDB on startup, so that it can give you debugging info if your C program crashes. Which is helpful, but really frustrating because now GDB and Valgrind need to be in the global scope. But let's have a look at Nix flakes and see how they make those somewhat trivial. So, first of all, we've got a description where we just say, yeah, DCC is the debugging C and C++ compiler. We grab our inputs, and I'm saying 25.05 at the moment. Then we go and we define all the list of systems we want to support. Then for each system, we go and we grab the packages from that system, and then we say, okay, for each system, create a binary called DCC, which has these build time dependencies, and then make a derivation where you say those are the build inputs, and then you use the make wrapper thing because we need to make a wrapper around it so that it can update the path variable and all that sort of thing. And then we just have install phase, and it is literally just the process for how you compile it. It's a little bit imperative, but it's basically just a couple calls to copy and a make file, and also copying GDB and Valgrind into the global scope, which feels like a hack, but works. And additionally, you can do development shells as well, and that's pretty easy. You just set up the packages and that sort of thing. Pretty nice. So yeah, now anyone who goes and uses that flake will get a fully configured DCC in NixOS, which is pretty awesome because, like, yeah, it was a bit of a pain. It took me a couple of hours to get that working, but now no one else has to get that working ever again. There's just one problem though. There are literally zero options otherwise, or at least no good options. Hypothetically, you can run arbitrary executables by setting programs.nixld.enable to true, which allows binaries to arbitrarily link to other libraries and dependencies. However, that didn't work for some programs, especially when I couldn't figure out how to install the libraries that those programs wanted. Basically, to have pretty much any non-Nixed program in your Nix configuration, you're going to have to go and Nix it yourself. No wonder the package ecosystem for NixOS is so huge. There are basically no options aside from creating a Nix package for anything that you want to be installed declaratively. And at that point, you may as well contribute the package upstream anyway. So let's look at some of those alternatives that I talked about. First of all is Mise en Place, which advertises itself as the front end to your dev end. So it has weak isolation based on a shell script that modifies your path variable as you CD about your system, which feels like a hack, but it works surprisingly well. So what does a Mise configuration look like? Look how easy it is to install Gradle 8.8. That's 17 lines shorter than that flake that I showed you earlier, and I don't need to find this random-ass commit hash to end up with the right version. Look at how easy it is to install literally anything from NPM. That works for packages written in Python, Ruby, Go, Rust, and more languages too. What if I want to install a random binary from GitHub? Literally, you can just do it. It's great. It's so easy. And what I love about Mise is that it's so easy to use and everything just seems to work. Like, it's worked on all of my systems with very little setup, and even better, it automatically changes the versions of packages depending on your current directory. So if I'm currently in a project that needs Node 22, it's going to activate it without me even needing to remember or ask. And then when I CD out of that directory, it'll switch back to the default version. If I gave a talk about that, I'd be done in literally 30 seconds because Mise is so simple and it's so good. However, it's not perfect. For example, not everything is handled by existing integrations. For example, JDTLS that I mentioned before, if you install that with Mise, then you're not going to get Java 21 as an isolated dependency for it. So if the tool that you want to install has complex dependencies that aren't handled correctly, you're going to find yourself writing Lua. And between Nix and Lua, I think I know which one I'd prefer. Like, I'm not even familiar with Nix, and it's so much better for this sort of thing than Lua. And you're going to need to go and create installation scripts that set up all of your dependencies manually, which is far worse than what it's like to solve similar problems with Nix. The other alternative is Docker. It gets isolation via lightweight virtual machines, which is probably way higher reproducibility than Mise, and probably even better than NixOS, at least without flakes. You're literally running the same virtual machine as other people. Additionally, all of your VMs are isolated, which is good for security, and you can use it to spin up development environments and use things like VS Code's remote server to do your work within them. So let's see what a Dockerized program looks like. So as you can see, the config file is very imperative. Unlike Nix, I don't say this is what I want. Instead, I say this is how to get there, which is much more complex most of the time. The build times are even slower than Nix, and it's much less secure by default because being in the Docker group on your system effectively makes you root. It's also much harder to learn. Because you're running a full virtualized OS, you essentially need to learn that OS as well as Docker. It's also comparatively slow to start and stop, which makes it a pain for development. I can't just open up a folder and start typing. I need to Docker compose up or whatever and then connect over SSH into the Docker image or something like that. It's really not fun. However, it does have some positives. For one, it's used everywhere, so there is probably already a good image for you to use as a base and so many examples to use as a starting point. Once things are Dockerized, running them is so easy with Docker Compose. It is excellent for servers and home labs. It's what I use for my server, and it makes everything an absolute breeze to run. So, overall, do you need NixOS? Well, you might not, but also, you might. So if you just want an easy setup of development tools, use Mise instead. It's way nicer for development work. If you're running a server, just use Docker. Writing Docker files is hard, but using other people's Docker files is easy. And there's a massive ecosystem out there for you to take advantage of. However, if you want to understand the state of your system without hunting through random config files and running random commands, NixOS is incredible. While it didn't just work, it worked a lot more often than it didn't, and I was able to configure some really advanced things which I wouldn't be able to configure on other systems very easily. I was a lot more impressed with it than I thought I would be. So do I need NixOS? It's complicated. I really want to love NixOS. It does so many things right, and when it works, it fills me with joy. It's so good, it makes me so happy. I want to take screenshots and share them with the world and be like, look how cool this is, it's great. But then I'll go and I'll update my system and it'll decide to compile Chromium from source and waste my CPU and my electricity. Which is, I love it so much and I hate it so much. So for the time being, I'm going to persist with it, but I'm going to be keeping an eye out for alternatives, and I hope that alternatives will crop up. So what does NixOS do right? First of all, it has an enthusiastic, helpful, and kind community. Whenever I had issues, I made a couple of Reddit posts and a couple of forum posts, and people were absolutely wonderful and pointed me in the right direction. It was great. It also has a huge package ecosystem. If you want a package and it has more than about 1,000 users, it probably exists on NixOS. It also has a huge amount of flexibility. When I ran into problems, working around them was always possible, even if it wasn't simple. So for example, with compiling Chromium from source, because of NixOS 25.11, I just forced that package and that package only to be compiled, to be built from NixOS 25.05, and everything else stayed up to date, but I held that one back for a little bit to the older version of the system. That was really cool. And finally, also, it's declarative. I cannot stress enough how cool it is to have a declarative operating system. However, what could be improved? I think first of all the documentation. NixOS is currently in the wiki wild wild west when it comes to documenting things. It's really hard to find a single source of truth when it comes to documentation. It also needs improved tooling, especially in terms of observability. Tools like NH are excellent, but they should be the default rather than just a thing that I found out about after complaining too hard on Reddit. It also needs better error messages when trying to run non-Nix software. For example, let me know what libraries I need to install. It also would benefit from a lot less boilerplate when packaging software. Flake.nix is okay, but it could be a hell of a lot more concise than it currently is, and things like Python or even Node's package management make it look pretty sad in comparison in terms of the readability of the configuration. So now that I'm not bound by my self-imposed rules, I don't need to stick to my all nixable things must be nixed kind of standard. As such, there is nothing stopping me from using a combination of tools. I can't live without Mies. It's got this awesome ability to install all the development tools that I need really quickly and really easily. The automatic activation tool is just the icing on the cake. Thankfully, adding it to NixOS is a single line of configuration. As such, my plans are I'm going to have NixOS for general system configuration and package management, Mies for management of developer tools such as Gradle and Node, Docker for deploying my software on my server, and for dot files management, I'm looking into Home Manager, which is a dot file manager for NixOS, but I didn't have time to experiment with it yet, and I've heard that it's pretty slow. If that doesn't work out, I'll have to keep looking. I haven't really found anything that works with my brain yet. So, yeah, there are no gods of purity watching over us, despite what the NixOS wiki may have you believe. So as such, you should do what makes you happy, and don't stress about making things perfect, because perfection will not make you happy. However, what I've found is that trying new things will, even if you originally thought you didn't need them. Who knows? You might just prove yourself wrong. Thank you. So, I've got a lot of people that I want to thank for helping me with the research and process of making this talk. First of all, Vim Joya has excellent videos explaining how to work on NixOS. Marcelo Lazzaroni has a really great blog post explaining how to search for and install old versions of Nix packages, including a tool that lets you go and find the right commit hash with a lot less stress, which is really helpful. Jade, I don't know her last name, but she wrote an excellent blog post saying that flakes aren't real and cannot hurt you, and I loved that. Ryan Yin wrote a book on NixOS and flakes, which I found really helpful for getting up to speed with how flakes work and what they're actually for. Additionally, I'd like to thank the official NixOS wiki and the other, presumably unofficial NixOS wiki, which both had very helpful information. There are also many kind and helpful users on forums such as the NixOS discourse and the NixOS subreddit, as well as countless others that I didn't think to take note of. But thank you to everyone in the community who made this project and this talk such a joy to put together. Goodbye.